who haven't spoken yet, my name is Kris, and I'm a data scientist at Connex One. I've been here for just over 2 years now, working on various speech-related projects, and I've since been entrusted with leading the speech team. So I'm here tonight to talk to you a bit about how automatic speech recognition is used at Connex One. And also, in case you weren't familiar, automatic speech recognition is when we use computers to automatically transcribe speech into text. And also, I'll be sharing with you some of our results in evaluating OpenAI's Whisper speech recognition system, which has been making headlines recently. All right, without further ado, just a quick overview of my presentation. I'm going to give you a quick rundown of Athena Speech Analytics, talk about some of the challenges of speech recognition at Connex One. Then I'll give you an introduction to the OpenAI Whisper speech recognition model, and lastly, finish off with some of our results of evaluating these Whisper models on Connex One's data. Athena Speech Analytics is Connex One's flagship AI product, and as Dimitri mentioned, it handles 15 million of customer agent interactions per day. And what it essentially is a data pipeline where we generate actionable insights for our customers just using their call recordings. So this is done by using Athena's speech recognition model, which automatically transcribes call recordings into transcripts. And then Athena's NLP, or natural language processing models, will then extract actionable insights from these transcripts. So as we can see from this pipeline, it goes without saying that having a high speech recognition accuracy and performance will lead to more accurate and useful insights for our clients. Which leads me to the next slide, speech recognition at Connex One. So as I just mentioned, Connex One handles a large volume of call center data, and call center data poses unique challenges in the field of speech recognition. Some reasons being disfluent conversational speech. So disfluent conversational speech meaning callers usually have hesitations, fragmented words, or there's noise events interspersed throughout the speech. Multiple accents, as Dimitri's mentioned. In contact centers and call centers, there's usually a lot of background noise and background speech because of the way that call centers are set up. On the customer's end, there's usually variable microphone quality, just based on different headsets that they use to call. And because of the way that the audio is being transmitted, there's usually high audio compression applied to the data. So we've addressed this in our data set. Our data science and data annotation teams have jointly developed a speech recognition corpus of approximately 1,000 hours now, and still growing rapidly. And using this corpus, we've trained Athena's English Excel model, speech recognition model. And yeah, so it's called Connex's Athena's English Excel model, which I will refer to numerous times throughout the rest of this presentation. As I mentioned earlier, speech recognition performance is really important to us. And therefore, in late 2022, OpenAI released a speech recognition system called Whisper. And it made a lot of headlines because of its high out-of-the-box accuracy and general user friendliness. So yeah, so we're going to introduce that to you. So OpenAI's Whisper model is based on classic transformer-based encoder-decoder architecture. It has two main features out of the box, which is mono and multilingual speech recognition in 97 different languages. Additionally, it's capable of transcribing audio from any of the 96 languages into English. And most notably about the Whisper speech recognition system is that it was trained on 680,000 hours of data, whereas most typical speech recognition models are only trained on thousands of hours of data, such as our model here at Connex One. And additionally, OpenAI states that Whisper approaches near human levels of accuracy. But the question for us is, how does it perform on noisy and high compression call center data? So there's 5 different pre-trained models. I'm going to go over that really quickly. Whisper has 5 different pre-trained models: tiny, base, small, medium, and large. And as the names of the models imply, they increase in the number of parameters, required disk space, RAM, and relative transcription speed. So those are the 5 models. We're going to evaluate all 5 of them, which means this leads me into evaluating Whisper. Before I can present my results for that, we first have to understand what accuracy metric we use in speech recognition, and this accuracy metric is called the word error rate. And the word error rate is basically calculated by summing the number of substitution, deletion, and insertion errors, and then dividing by the total number of words in the reference. So in the below example, we have the reference transcript, or the ground truth, or the human-generated transcript, which says, "Good morning, you're speaking to Connex One support." And then we have the hypothesis, or the computer-generated transcript, which here says, "Morning, you're speaking to Connex One sales." And then using those two, the reference and the hypothesis, we can perform our evaluation, and which is usually done programmatically. But here we have an example. So here the word "good" is omitted in the hypothesis, which is a deletion error. The word "your" is misrecognized as "you are," which is both a substitution and an insertion error. And the word "support" is misrecognized as "sales," which is another substitution error. And as I said, the numerator here is 4 and the denominator is 8, so the word error rate is 50%, which is quite bad, but yeah, this is just an example. And lower word error rate is better, with 0% being a perfect score. So now that we know what the word error rate is, we can start looking at our results. So the first thing we did was apply the 5 different whisper models on 20 hours of English data with varying speaker accents, domains, and noise conditions. So on the x-axis here, we have the 3 different domains: cellular services, TV services, and debt management. And on the y-axis, we have the word error rate. And remember, a lower word error rate is better. And from left to right, the colors are the English Excel model, Whisper's, Connex's English Excel model, Whisper's tiny, base, small, medium, and large models. So what we can see out of the box is that the Whisper speech recognition system achieves really competitive accuracy, even though it was not trained on any of these domains. Well, they could have been trained on these domains, but they were not trained on the same domains that we have here at Connex One. And yeah, so the out-of-the-box accuracy is very good. And additionally, in the case of debt management, in the domain of debt management, the Whisper medium and large models actually outperformed Connex One's English Excel model. So out of the box, the Whisper models look really promising. So the next question is, what would happen if we fine-tuned some of these models? And what we did was we picked the Whisper small model to fine-tune. And the reason we picked the small model was just to balance the trade-off of speed versus accuracy. And yeah, so we took the small model and fine-tuned it on the domain of home improvement data. And then we evaluated that fine-tuned model on within domain and out of domain performance. Again, on the x-axis, we have home improvement, belongings insurance, funeral planning, and debt management. And on the y-axis, we have the word error rate. And this time from the left to right, the colors are the Connex English Excel model, the small Whisper model out of the box, and the small Whisper model that was fine-tuned on this first column here, the home improvement data. So what we can see is that after fine-tuning the Whisper small model, the word error rate greatly reduced, which is good. And in the case of in-domain performance for home improvement, it actually outperformed the Connex English Excel model by quite a significant margin. And equally notably, in terms of out-of-domain performance in funeral planning and debt management, it actually managed to outperform the English Excel model as well. So from this, we can see that the Whisper models have really promising accuracy, especially once we fine-tune them on these call center contexts. However, before we can just insert this into the Athena Speech Analytics pipeline, we also have to consider the latency of these models and how much memory they require, which leads me to load testing. So what we did was measure latency and memory usage of the English Excel and small models by running concurrent processes. So by running a variable number of concurrent processes, with each process transcribing a 10-minute file on a machine with 8 CPUs, 32 gigabytes of RAM, and no CPUs. And before I show you the table below, just note this term we use to measure latency, which is called RTF, or the real-time factor, and that's just the inference time or the recognition time divided by the audio duration. So below we have the load test results. On the left we have the results of the Connex English Excel model, and on the right we have the results of the Whisper small model. Just at a glance, we can first see that the Whisper small model requires about 5 times more RAM than the Connex English XL model. Additionally, if we look row-wise, we can see that even in the best case scenario with 2 or less concurrent processes, the Whisper model takes approximately 2 to 3 times more, needs 2 to 3 times more time to decode the same amount of audio. And if we go into 4 or 8 or 16 concurrent processes, let's take, for example, 8 concurrent processes, it actually takes 16,000 seconds to transcribe 8 10-minute files concurrently. So 16,000 seconds to transcribe 80 minutes of audio, whereas the English XL model can do that in 101 seconds. So yeah, from these results, we can see that Whisper has really good accuracy. However, the latency and the latency is just too much to insert into our Athena Speech Analytics pipeline at present. So the takeaways of my presentation are that out of the box, the Whisper speech recognition models have really good performance. However, and additionally, these models can be fine-tuned to further surpass the accuracy of the English XL model. However, Whisper is extremely computationally expensive and in its current state cannot handle the large volumes of data that we process at Connex One. But on a more positive note, we can use these fine-tuned Whisper models and we can integrate them into a computer-assisted transcription pipeline to help improve the efficiency and accuracy of our data annotation team. And lastly, we'll be keeping a close eye on Whisper because it's still being actively developed. There's a project called the Whisper.cpp, which is a lightweight C/C++ implementation, as well as people have been applying dynamic quantization, which is the method of using reduced precision integer representations of the weights and activations in the speech in the Whisper models. And both of these work to help increase or to help decrease the latency when transcribing with Whisper. And that concludes my presentation. Thank you very much.